Alright, time for another debatephysics.com video presentation. So on the debatephysics.com website, the simple website, there is a group of these short 5-minute or so videos, and the second one labeled 9.8 meters per second every 1 second. Okay. I'd like these people to reply to the video and explain how something I'm saying in the video is incorrect. It seems clear that gravity is time dependent, that it doesn't care about the distance, that I could set up a distance in a gravitational field and the distance isn't going to decide how much gravity pushes the object. What's going to decide is how fast it moves through that field. The faster it goes through the gravity, the less the gravity affects it. I mean, that seems an undeniable fact of how gravity is acquiring. That's how you acquire energy from gravity, is to spend some time free falling in it, falling in it, frankly. And that's it. It's, you know, there is no kinetic energy component. There's just the force you collect from gravity. You're in gravity for 2 seconds, free falling, you collect 2 units of force, you don't have 4 units of it. And if you're in it twice as long, it means you've traveled 4 times the distance, which means absolutely nothing. Because all you have is twice the velocity, and you'll land with twice the weight. Alright, now, experiments defending the kinetic energy theory. I mean, there are none, okay? It's just a fact. And it's really irritating that they just won't concede that there's a real lack of evidence, that these elemental experiments haven't been done with levers or other devices to attempt to do what Joule did. And even Joule failed in his own effort. I mean, Joule was really trying to find the difference between a steam engine and an electric engine, a motor, in terms of efficiency. And it really wasn't that easy to derive. It wasn't that easy to find out the right answer, because it's not easy to actually collect something's energy. So he had to make water tanks and all kinds of things, but there's no perfect way to connect these things together and all of that. So, you know, there's real science that still needs to be done, and they haven't done any of this science. So anyway, well, let's start with one of his comments after I had made my video. In fairness to DraftScience, so this is Watto, he's never fair, so it's just, you know. He makes a valid point that the latest video about potential energy, so the latest video was about electricity, and an argument made making a comparison between water and electric wattage, you could say. So the force of water and the force of electricity, and they do have a lot of really great parallels. But the guy just made a simple mistake in terms of saying that in gravity all you do is lift something twice as high to get twice the energy. It's a mistake I have made in the past. Although the point is not original to him, so whatever that means. I mean, obviously the guy made a video, and he isn't going to correct the video if no one points out the errors in the video, right? So, I mean, okay. I'm the one who pointed it out, okay. It is wrong to say that an object has this much potential energy. Well, that's part of the subject, right? That the whole subject of potential energy is nonsense. That they have given reality as if potential energy is a substance, when potential energy is a condition something's in. Now, a battery has real potential energy. A spring has real potential energy. But something falling in gravity doesn't. Alright. Potential or kinetic energy, I don't know why he would throw that word in. Obviously, potential energy could be well understood to be potential momentum. I mean, the MV is in kinetic energy. The first thing you do is momentum, MV. You can't have kinetic energy without first talking about momentum. So, it seems you have that backwards. Okay. It is not a property of objects like mass or charge. It is merely a description of the object's location and motion worked a given field. Whatever the field is physically. So it's a circumstantial. energy. It's not possessed yet. Okay. So the stream, the Mississippi River, has potential energy. You can say it has potential energy. The boat sitting on the shore doesn't really have anything. And it won't have any energy until it collects it. It can't collect it as potential. It has to collect it kinetically, actively. All right. PhysicistMichael pointed this out, whatever this is, in the relative KE video, but verbiage is so ingrained in our everyday talk, everyone slips up all of the time. Well, I don't remember any pointing out of anything relevant, but whatever. All right. So I posted my response. Then Woto guy says again, some have actually tested these things for themselves. Now, I don't know who said that, but who cares? Again, why should we have to test it for ourselves? I mean, it's 500-year-old physics, a lot of this stuff. Certainly Galileo, Newton, and Descartes did lots of experiments. Now, obviously, we don't have videotapes of those experiments, unfortunately. And then we have examples of experiments done in the 1700s with the Chardonnay that convinced people that were clearly poorly reasoned experiments. Okay, dropping round things into clay, denting clay with round things is not good theory, as I have pointed out. It won't get you a right answer. It won't produce a result that's consistent with the truth you're seeking to find. Okay, it's a deception. It's a circumstance that can be understood to create a distortion in the outcome. Now, can we get PhysicistMichael to concede that the 1740 dropping round things into clay experiment was bad physics or bad science? Can we get him to concede that people shouldn't have interpreted that the way they did as solid evidence of 4 times the energy when it really wasn't real? And then I've pointed out, people have pointed to, look, it rolls 4 times further because it's going twice as fast. Now, I've pointed out that it's going half its speed after it's going 3/4 down the track, pointing out how gravity is controlling the friction, that there's less friction while it's going fast than there is friction when it's going slow, that it loses more energy as a fact the slower it's traveling. Those are facts. Those are real arguments. Have they been countered anywhere? No. So, I mean, you're just so full of crap. Where's your evidence? Where are these experiments? We have no indication. We have no experimental evidence even indicating it takes 4 times the fuel to go twice as fast, or that it takes 9 times the fuel to go 3 times as fast, or 16 times the fuel to go 4 times as fast. Not even a glimmer of evidence. And we don't even have any crash test evidence indicating that when something's going twice as fast, it makes 4 times the mess. We have nothing as evidence. And it's just amazing. So he says many of the experiments are done routinely. What experiments are done? The same old air track experiment over and over and over and over and over. One experiment over and over. Crash a 1 mass into a 2 mass and make free momentum. The consequences is free momentum. So you're making free momentum. Kind of a bold, weird thing to be doing. Sort of, it should be a little bit paradoxical even to complete morons like you. You should be at least saying, wow, that does seem a little strange how you can get away with that. You know, that you can make free momentum, it doesn't matter. It's not breaking the laws of physics. Amazing. Routinely in high schools and colleges around the world, but DraftScience insists on broadcasting his cluelessness. So, no, I insist on making counter-arguments to those experiments and pointing out there are other experiments that say differently. And, that violating momentum, the conservation of momentum, is, frankly, I don't see how it can be theoretically fertile ground. How you can ever prove that, 1 atom moving 1,000 miles an hour is more energy than 1,000 atoms moving 1 mile an hour. Where do you have that experiment? Okay. That is why the world ignores him. So, yes, no one's ignoring me. Obviously, the internet is not an easy to slide into the viral popularity stream. It's a closed medium in a lot of ways, and a lot of people are suffering because of that. PhysicistMichael, for example. Lots of people have made very good videos over the last 10 years and gotten nothing for their trouble. It's just a fact of the crapanet that you people are sort of the definition of. All right, with a contemptuously dismissive, is that so, LOL. Whatever. I'm dismissive because, yes, there's evidence that directly contradicts those experiments, like, for example, the Newton's cradle. If this one mass hitting two mass thing actually happens, why don't we have any documented case of it happening in a Newton's cradle? It's about as perfect an elastic condition you can get, the medium. You get almost, 99% of the energy is conserved, whatever you think energy is. With each impact, it's incredibly conservative. Why don't we have any evidence of it then? Why haven't they done that experiment in hundreds of millions of labs? And why haven't the high schoolers and the collegers done that one routinely over and over again? Showing us how, yes, look, free momentum. It's this easy. You just bang a thing against another thing. Free momentum. No, nothing. All right, now I don't think I'll bother with the Walker comments because they're just too stilly usually. Potential energy. The potential gravitational energy is in fact a negative energy, so we'll just forget it right there. It's negative energy, unenergy, whatever. Anti-energy. This is a guy who believes in free energy, so it's a waste of time. All right, so Gosling says to the Walker retard, let's see if this, I'm not going to go through this crap. This h equals 1/2 gt squared, says you. The fact that that is true doesn't have anything to do with the fact that it's not 4 times the energy. It's only twice the force. There is no such thing as a squared second, so you can keep squaring seconds and telling me that makes sense, and I'm going to keep saying quite obviously, it's obviously just a gimmick. The square should actually be somewhere else. There should be some other term in here, okay, that you're squaring, not that one. When you want to know the momentum instead of the energy, use a different formula. Duh, because mv is right in the middle of the kinetic energy formula, so you're just telling me that, yes, you just make it up. When you want the kinetic energy answer, you square it. When you want the real answer, momentum, you don't square it. Durr. Okay, so he says here, kinetic energy. Gravitational acceleration g is just another acceleration, a, whatever that means. And drop height h is just another distance traveled, s. So I don't know why s would be the distance traveled. But again, as I can point out by illustrating a flyby, something going by another planet that has gravity, that I can have exactly the same distance. And I just change the speed with which something travels through that distance, and I've changed how much gravity there is. That formula won't get the right answer, because the distance doesn't matter. The time matters. So anyway, fuck them. Alright, Gosling says, Dear John, you are more likely to get an intelligent response asking a duck. Okay, that's really useful crap. Boy, you're so smart. What a challenging counter argument. How am I going to deal with that? Ooh, he says I'm dumber than a duck. Should I go with the shoelace joke? Yeah, you're dumber than a shoelace. Alright, timestamps for DS video. So this is PhysicistMichael. This is probably a waste of time. Yeah, we've already established it's a waste of time because you view everything through your narrow little structure and you won't open your eyes and expand that structure. I really do think you're quite aware of the fact that you can formalize the same objects in a formula. You can create different formulas that'll all get the same answer. They'll look very different, their structure's very different, some are the long form, some are the short form. And here you're pretending that there's no way to make an association between the fact that there is this 1, 3, 5, 7 relationship to how you acquire acceleration in a gravitational field, and that you can't use that to come up with 9.8? Of course you can. But anyway, but here we go one more time. So at 34, I don't know why it says 34-25. I don't know what that means. 34 minutes, 25 seconds, I guess. I don't know. My math is dogmatic, question mark. It's dogmatic, yes, of course. I'm clearly stating that mgh is not correct, right? I mean, it's a time-dependent force, so saying mgh, you know, thinking the height it matters, no, the time matters. And I think you know that. And I think you just know that, well, I can always associate the height with the time because the two things are basically connected to each other when you're talking about an acceleration. So in some cases, like falling, there'll be that correlation. But it's not going to be a correlation in all the other examples of interacting gravitational bodies where the constant force is involved, because the distances won't be proportional to the time, because they're not free falling. They're coming at some other angle. It only works in this one case. So you're using math that only works in one case, and I'm arguing that no, the math that works in a lot more cases is the math that understands that it's just about how much time something is exposed to the gravitational force. Alright, no, it's just one done correctly. Whatever. Is it dogmatic for me to say that 2 plus 3 equals 5? So again, claiming that this is some sort of, he's proven there's no other way to understand gravity than understanding whatever a square second is. That it's not a fact that Newton said that the gravitational effect, small g, equaled, whatever he said, 16 feet per second. That's what he said, okay? You're saying something different. You're saying something different than Newton said. All right, you're making an argument for some revision of the answers that, you know, where he got lots of right answers using 9.8 meters per 1 second. You're saying that he got wrong answers? What are you saying? I mean, it's clearly understandable that that's exactly how gravity works. Each second you get 9.8 meters of velocity. That's the absolute truth. There's no reason to square it. I mean, and you're claiming you're defending the foundational elemental truth here? No. You're defending an abstraction, a perversion of that simple truth. Okay, I know you said math isn't your strong suit. I said I don't have much interest in it. But this is really basic. Says you? A square second is very basic? There's absolutely nothing basic about a square second. Jesus. If you take the velocity, okay, mass divided by seconds, and divide by time, why would I do that? Why would I divide by another unit? I'm just going to divide by the time. I don't need to say now the seconds are squared because I divided by a second. If I divide by a second, I just cross the seconds out. I mean, there's lots of ways to look at that where why would I make it seconds squared? Which is right there on your screen. You get meters per second squared. So I don't know, maybe in your book you do. So if I divide a meter by a meter, I get meters squared. So if I divide 3 meters into 6 meters, I get an answer that's squared. Squared meters. No, I don't. Anyway. Sure, introduce a new configuration, but it's still a velocity divided by time. That's mass times seconds squared. So you're not allowed to reconfigure the equation. And clearly, I don't need to square a second. I don't need any squared seconds. It's 9.8 meters per 1 second. So even if I square the seconds, I still have a ratio that says 9.8 meters to 1 second. Okay, so put your 1 there and then square it and see where you can go. It's 1 second. It's not any number of seconds. So again, you can keep lying. I mean, yeah, I'll draw this on the board, but I mean, isn't it just a lie for him to pretend that this squared thing could possibly make any sense, even as He's stating it's a ratio. This is the truth he's seeking. Okay, and what is the absolute truth? The statement I'm making is it's 9.8 meters per, okay, meters per 1 second. All right, they just leave the 1 out, but it's there. It's not per any number of seconds, right? It can't be any number because this changes. If I make this a 2, this has to change to 19.6. If I make this a 0.5 seconds, okay, then this has to change to 4.9. So this has to change if I'm going to change this. It obviously has to be a 1. It can't be anything else. So what you're really saying is you say this is the real formula, 9.8 meters per 1 second squared, which is just going to be 1 times 1, which is 1. So it doesn't make any difference. Your own ratio is in fact saying exactly what I'm saying, which is 9.8 meters per 1 second, because 1 second squared is still 1. So you can't use this thing. You can't pretend it's 9.8 meters per any seconds. Okay, seconds, seconds with an S. Should I put a big S? 9.8 meters per, who cares what number of seconds? Yes, it's 9.8. You can be any number of seconds in the universe. Any number at all, and you still get 9.8. That wouldn't make any sense. It's 9.8 meters per 1 second. Again, I just, how, this is what Newton found. This is what he discovered. This is his great discovery. It's 9.8 meters per 1 single second. And you're claiming you have authority to say that trumps this, that's better than this, that you have some explanation that's better than this simple statement. It's 9.8 meters of real stuff. Okay, well, it's velocity. So you only get 4.9 meters of real distance, but your velocity will be 9.8 meters per second. That will be your velocity, and that is the rate you got those 9.8 meters per 1 second. You got them per 1 second. Not per any seconds, and not per any second squared. Hold on a second. Alright, I'm back. Okay, so let's see where we were. We aren't getting very far. I have to go a little faster than this. Sure, introduce a new configuration, but it's still velocity divided by time. That's mx squared. Every time that you say something like you get 9.8 meters of velocity, I cringe inside. So that doesn't make any sense, right? Because that's the status of it. In 1 second of free fall, you now have 9.8 meters per second is now your velocity. That's what it is. You acquired a velocity. Why is it something wrong with me saying 9.8 meters of velocity? It's a 9.8 meters per second of velocity. I mean, okay, I'm leaving out the per second because I don't, see, that almost seems redundant. To have to say the second is almost being redundant. To say it twice. Yeah. Meters aren't units of velocity. Well, they are in this context, because you're basically saying how many meters per what distance. Okay, so it's the same difference as saying in what time. There's no difference. All right, it would be meters per second, and this repeated error from you is what is causing the issue. So again, it's just absolute nonsense. I've said meters per second millions of times, so it's really not an issue. I think everybody on Earth who has listened, who's graduated high school would know what I meant by 9.8 meters of velocity. They would know what that means. But whatever, pretend they wouldn't. Okay. You wouldn't say that you're driving down the road at 20 meters. And again, so I don't know where he's getting this from, but it's clear that in the 5-minute video I say 9.8 meters per second is the velocity. So who is confused? Who thinks we're measuring in something other than seconds? Realistically, who the hell thinks so? Absolutely no one. And then when somebody talks about going 20 meters, well, frankly, Americans don't do that. They say you're going 20 miles, and they always say per hour. Okay, So if you don't want to sound ridiculous, stop saying that velocities are measured in meters. So I still don't understand why he's complaining about the meters part. It's meters per second. I don't think there's any, I mean, I haven't heard this accusation from anybody, so I really don't think this is a real problem where so many times I didn't say the second part, per 1 second. And I don't even say the per 1 second, but that's what it really is, 1 second. So why don't you stop doing that, okay? If you don't want to sound like a liar and a deceiver, why don't you say the 1 second squared part? 9.8 meters per 1 second squared. Why don't you be honest and say that part? Ridiculous person. Shit. Anyway, all right, 3440. There's a huge relationship between time and distance. When you're free falling, okay, you're guaranteed it in free fall, okay, because of the rules. But in every other circumstance, your velocity decides your distance. All right, that's exactly the thing we're trying to measure. You're trying to measure it. It's not me. The real thing that's quadratic is the distance. So that's what I said. You know, so these are my quotes apparently. At least these two are. All right. That's exactly what that constant acceleration equation is doing. So he says squaring the time is somehow getting to the fact that he says the time is quadratic overtly in his video. That's his accusation, quadratic time. He's proving it. That's what the square means. The time is quadratic. I'm merely pointing out that no, that's a misplaced statement because the only thing that's really quadratic is the distance. The time isn't quadratic. All right. The distance m is quadratic in time. So no, it's quadratic as an absolute. In the fact that it's reoccurring velocity. It's velocity you never lose. So you just keep adding to what you've already collected. And what you're collecting is quadratically increasing. Alright, gets t squared term when there is an acceleration. So again, the acceleration is not quadratic. The acceleration is merely 9.8. So if I'm going 500 miles an hour heading for the Earth, there's obviously nothing quadratic, okay? There's going to be a huge quadratic increase in your distance. So you're going 500 miles an hour, and I'm going to add 9.8 meters. Well, let's say 500 meters per second. You're coming towards the Earth. In the first second of the gravity, which is a long time going 500 miles an hour, you're going to be only adding 9.8. So you're only going to be going 509.8. And the second second, it's only going to be 519. So I've made this exact argument 3 times, 4 times now, and it's just not paid any attention to. So clearly the time is not quadratic. The distance is. All right, so 4550. If you measure velocity, you're talking a distance divided by a time. If you divide that time again, that's distance divided by time squared. So says you, whatever. Not interested. You don't need to square any times. Alright, not in my reality. I know that's not true in your reality. You've constructed your own. No, it wasn't just mine. It was Galileo, Descartes, and Newton's reality also. Yours is Leibniz's reality, the guy who called it the living force, and the guy who believed in solitons and monads. And by soliton, he meant religious soul. You're so close. Your velocity is in meters per second, and then you're dividing by another time to get... I'm not dividing by another time. I'm multiplying by the time. So that's just not correct. I'm multiplying by the fraction, okay, that puts the time back into 1 second units. Alright, this really shouldn't be that hard. Whatever. You can just make up the data. Are you kidding me? That is your level of rigor. I'm saying you could make up any example of anything traveling in gravity because we already know these facts. You don't need to do the experiment because it's already been done 1,000,000 times. I mean, yeah, probably there's a million recorded events of something shot into the air. I mean, there's probably a million. Just the launches that people have done are probably in the hundreds of thousands. So what do we need that data for? We could just pick any numbers that are coherent to an example, and no problem. All right, if you don't do math and you can't do physics, unfortunately, at a certain level, yes, that's correct. And that would argue that's where you people have gone way off the reservation. Okay, you've left the reasonable building, because physics is really just a model, and it's a model that you can simulate, and it's a model that yes, you can do it the hard way, mechanically. You can draw a picture of the graph and you can see the line and you can measure it with a ruler, or you could use a mathematical formula. But I think it's just wrong to think there's any formula you have to know to be able to understand conceptually what's happening, the relationships between things, because it's all momentum, frankly. But whatever. Believe what you wish. You wouldn't hire someone who can't do math to do your taxes. Again, if they knew how to count beans, I would. So yeah, maybe it'll take them a little longer because they'll actually count it, or they'll cut out little pieces of paper representing the assets, and then they'll manipulate those pieces of paper physically and calculate what my tax bill is. So yes, I would. So again, you're just arguing that you have to do these, you have to speak your Latin to be a doctor, when no, you don't need Latin to be a doctor, and you don't need math to be a physicist. Alright, you wouldn't hire a carpenter who can't use a hammer. So again, it's a very poor analogy, because your synthetic tools are just that, synthetic. They're holograms. They're not real. They can't hammer a nail. Okay, you can't prove anything with your math. Alright, if you don't know how to use tools, so he's just going to say the same thing over and over again, of a profession, you're going to have a lot of trouble doing that profession. So again, he's saying physics is math, and I'm saying physics is conceptual knowledge of physical relationships. It's really made out of just experiments and understanding and putting all the experiments in the right context to understand the dynamic of the object. So you could deduce, as Feynman did, that so somebody says photons are a wave, and then Feynman points out, but they do these 2, 3, 4 weird things that aren't wave-like. Okay, I can't spread them out. They're not quantized. They don't land as clumps. They don't land in one spot. They don't do any of these things I need them to do to fit the evidence. You didn't have to do any math to say that. All right. And if you can't do math, oh, here he keeps going, you're not going to have the tools to evaluate the evidence for all those topics that you list. So again, I didn't say I can't do math. So again, I just don't have any interest in doing convoluted, abstract nonsense math. I'm saying you're starting with a false premise, a square second. There's no such real unit. It's not a real idea. Because what the second is there for is to replace the silly talk where you said per second, and nothing happened per second. There's no quantity called a per second. It's not a real thing. Per second isn't 2 seconds, it isn't 4 seconds, it isn't 7 seconds, it isn't any number of seconds. It's a nonsense statement. So you took a nonsense statement, turned it into a square, and there's no such thing. It's all just rubbish, nonsense. And this experiment doesn't have complicated math. Well, from my perspective, it's complicated in the sense that you're just inventing units that shouldn't even be there in the first place. You're saying that I'm going to take a number and then I'm going to make it a ratio. And you didn't put meters in the top, but you're going to put seconds in the bottom. That kind of thing. No reason to do it. Again, if you start with your beginning statement and then, and before your derivatives, in a lot of cases with you physicists, if I solve the equation before you start doing your derivatives, I won't get the same answer that I get after you did your derivatives, right? So your first equation that has missing variables, well, if I know those variables and I put them in, I'm not going to get the same answer that your solution creates. And that's not good science. All right. No calculus or trigonometry. Oh, it just goes on. Let's see. If you can't recognize that velocity in meters per second divided by a time, so again, it's just the number that you're dividing by the time. Okay, you're not dividing meters in seconds. You're dividing the number 9.8 or whatever your number is. The numbers are divided. The units aren't being divided. Just the number is. It's strictly just a number. It's 9.8 divided by 3. There is no dividing seconds into seconds or dividing meters into meters. There's none of that necessary. It's just a straight-on division. Just like in my example, right? There's 3 units of time. 3 units of distance. So obviously whatever answer I get as an average velocity, I have to divide by 3. I have to multiply by 1/3. The 1/3 I'm multiplying by doesn't have any units. There's no reason for me to put seconds there. There's no reason for me to create an artificial seconds. I don't need them. All right, if you can't, let's see. I'm not going to have a high confidence in your ability to evaluate anything. Well, I'm sorry, but that's not my standard. All right, my point is I'll pay you, okay, to make a counter argument to the arguments I've made. Take the video where I explain what gravity is and explain how I said something that you can prove to be inaccurate. Okay, and if you think that your inability to do math means you're not required to defend your position, so again, I have defended my position. I've got 12 5-minute videos. I made it really easy for you. Making the statements is, in a sense, a little bit reckless, because you can't deal with details. But they're bold statements in every single one of those videos, and you should be able to find a place where you can take hold and say, there, I got you. So go ahead and do it, or prove my point that you don't have a counter argument. If you had one, you'd make it. All right. Required to defend your positions with data. So again, he's using this data point. So he's defending 1/2 mv squared by proving that what goes up comes down. He says that proves 1/2 mv squared. No, it doesn't. Not by a long shot. Then that demonstrates your lack of understanding of how evidence-based reasoning works. So again, they have no evidence. So this is still the same guy who I keep pointing out. You can't show me it taking twice the fuel to go, 4 times the fuel to go twice as fast, or 9 times the fuel to go 3 times as fast, or 16 times the fuel to go 4 times as fast. You can't show me anything going twice the fast doing 4 times the damage, or anything going 3 times as fast doing 9 times the damage, or anything 4 times as fast doing 16 times the damage. You can't show anything at all as evidence. And here you're saying you need data. Where's your data? All you have is silly little carts banging into each other. Again, I'll point out, well, then show me why. Explain why it doesn't happen in Newton's cradle. The thing that has a perfect almost friction coefficient. Right? So unlike your carts, we don't have to worry about angular momentum. We don't have to worry about springs. We don't have to worry about any bullshit at all. We got a perfect elastic collision. All right? 100% of momentum is transferred all the time, routinely, no problem. So why don't you explain why it don't work? Oh, you're just so dishonest. Anyway, edit. This is certainly not to say that people who struggle with their math skills are barred from participating in science. We just said that, basically. There's no reason to pay any attention by me or anyone else. Science and learning in general is a participatory practice. Well, in your opinion, the whole point is to say stuff that's accurate. The whole point is this is a trial, a really serious trial. And basically the scientists were supposed to be the detectives, and they're supposed to have a whole bunch of evidence compiled so the prosecutor or the defendant can sit there and present the evidence and show the truth. And where are you doing that? All you're showing me is arrogance. You're not showing me a truth. You're not showing me how twice the force equals 4 times the energy. You're not showing me how that makes sense, that twice the weight equals 4 times the energy. You're not showing me how that makes any sense. Okay. If you want to know how to do science and math, start asking questions. Oh, brother, like, why haven't they repeated the Eddington experiment from space? Oh, yes, right. You ask the question and never get an answer. Ever. Now, Pirro gave a half answer, and he said, well, the Hubble telescope, its eyeball will blow up. You know, it can't look at anything too bright. So that's the answer. So even though you're not supposed to be looking at the sun, you're supposed to be looking pretty far away from the sun, actually, to do the experiment correctly. You're supposed to be well out a couple of diameters, maybe, away from the sun to do it ideally, to be as far away from the particles as possible. Those are the bullshit answers you get. So they can't put a GoPro in one of the space shuttles. They couldn't, you know. There's no real good explanation. It's just nonsense. Do research. Yeah, and my claim is you haven't done it. Go look up what Leibniz's great arguments were. God says so. That was essentially his great argument. God wants to have control of the universe, and the only way he can have control is we have to make energy wooey. So that's his great physics argument. Learn the skills that you need in order to take part. And just, oh, this is so pretentious. I'm an educator. Oh, brother. Them that teach can't. Yeah, right? Those that can do. Those who can't teach. Brother. And I work hard to help my students develop the skills they need to use measurements and observations. And the point is, I would argue, is you're just warping their understanding of reality with nonsense. Okay? Unproven, really bad physics, really bad science. Really, really bad. Way the fuck off. Okay, they need to put in the work if they want to succeed. Yes, and be a brainwashed colleague in the search for the neutrino. You also need to put in a kind of work in order to demonstrate your positions based on real physical data. So again, more baby talk. I'm saying I'll pay you to play a 5 fucking minute video where I explain how your wave particle is bullshit, and where I explain how your model of gravity is absolutely nonsense. Okay, that it's clearly a time-dependent force. Will you play one of those videos? Coward. Alright. 47.05. On the redoing the Eddington experiment. Ah, here we go. Alright. It's only one sentence. I can see that it's only one sentence. So I'm just afraid to look. I'll only read it word by word. Yeah. Okay. For these links, replace the underscores with periods. There's not going to be any links. So it's just fake. And clearly I stated from space. Clearly that was a challenge. And we know they haven't done it from space. They haven't. The Eddington experiment is an optical observation. You optically observe a sun and you watch it move erratically, okay, because of light being bent by the sun. It's a very specific experiment. So this is more bullshit. You ask them to show you it taking 4 times the fuel to go twice as fast, and they give you braking data. That's a long way from proof of anything, let alone proof of 4 times the velocity 2 times the velocity requiring 4 times the fuel. Alright, here we go. For a small sample of some of the follow-up tests that have been done. So this is just more lying. I mean, god damn it. It's clearly a specific experiment. Any experiment where you get back scattered data is not the same experiment. As I have pointed out over and over again, the whole point of doing the Eddington experiment outside the corona of the sun is one of the arguments. Clearly, any experiment that doesn't do it outside the corona of the sun would be illegitimate just because we know that's going to be scatter. Oh, Christ. That's just so bad. Do you want a definition of radio waves? See, here we go. Clearly, the Eddington experiment is about an optical observation. Okay, you have to actually see a sun. You watch the sun move. Okay, it's an object being optically resolved. Shit. Which match GR predictions to an accuracy of 0.00033. As pointed out, any light that scatters automatically goes to every single location. Now, whether it proved twice the bending to this number, I tend to laugh. Okay, so I'm sorry, that didn't happen. Because even scatter can't bend it twice. Alright. Are the measurements of signal from the Cassini mission being deflected? So all this kind of blah, 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 blah. So I'll grab that link. I don't know why you don't think you can post a link. You can post links in your own video, especially. I posted a link to my response video. It's in your comments section. It is possible to do. Alright. Are the satellite-based measurements of star positions using the so this one is even worse, this hippocampus one thingy, because I looked that up and it's complete shit. Alright, that experiment, complete pile of shit. Alright, and so he's got 3 of these dopey things. There's dots in here. I don't think that's gonna work. Weird. Okay, replace the underscores. There's no underscores. There's ... So I don't think these are going to work. This does not have the look of a frickin' proper. Alright, the underscore is a dot. And the ... dots, I don't know. That's just not going to work, I don't think. But whatever. These are all the same website, though. So maybe that's how they identify their web pages, with this weird crap. Anyway. Okay. I'm sorry that no one sent you the memo, oh brother, on these. So they're obviously not the Eddington experiment. So let's just understand, they're nothing like the Eddington experiment. They're radio, and they're sending all kinds of different kinds of energy, and they're receiving energy in all kinds of different ways, but they're not watching a physical object having its light lensed by the sun. That's what's not happening. Or Jupiter. So it's not in any way the Eddington experiment. It's not the 400 times better resolution from space experiment. Shit. Alright. Anyway, sorry you didn't get the memo. What a pile of crap on these. And you seem to lack the ability to use Google Scholar to look up what's been done. So again, claiming the existence of evidence that doesn't exist. So he did that in his video. He says, oh, there's already lever experiments that have been done. Oh, that's been done. I just don't have any references. Well, show some fucking references then. I'll put you to the challenge. Can't you use Google Scholar and show me an experiment that proves that it takes 9 times the fuel to go 3 times as fast? Why don't you just show me the link to it then, if it's an already done experiment? Why don't you show me a lever where they explain how a half mass can't go twice as fast? Why don't you just show me that fucking experiment on Google Scholar? Because you can't do your research, you fuck? Why don't you have any better links than this on all this whole subject? This whole kinetic energy subject's been going on for 2 months with you, right? More than 2 months. Why haven't you used Google Scholar to show me all this plethora of evidence you have? Oh, that's right, you don't have any. You had to reference a Gosling video. That's how bad your evidence is. You had to resort to linking to one of his shit videos. Oh, amazing arrogance. Amazing, this arrogance. Alright, use Google Scholar to look up what's been done. But your ignorance is not the fault of modern science. Modern science that doesn't need any what's evidence? We don't need evidence. We don't need proof. We're believers. Okay, and I'm sure this was a waste of time and that you'll just flat out deny. So this is bullshit again. You're the one flat out denying, right? I mean, I'm clearly pointing out they have very little evidence of anything they claim, right? Whether it's superposition or whether it's entanglement, doesn't matter what it is, their evidence is always this obscure, foggy, little Sasquatchy kind of image. And that's all they ever present. All right? They don't overwhelm you with facts and evidence. They overwhelm you with bullshit and jargon and arrogance. We all believe it. Don't be you don't want to not be a pepper. Be a pepper like us too. Be a pepper. We're the really cool Borg. God damn. These and any other evidence that infringes. So let's just understand, if any of these images are produced by shooting fucking energy through the corona of the sun, okay, not well outside the lamb of the sun, okay, a NASA engineer stated, a NASA laser engineer, okay, proven, 30 years worked for NASA, stated NASA has no evidence of bending outside the lamb of the sun. No evidence. That's his direct statement, a 30-year employee. I don't think he could say that. I don't think NASA would let him say that, all right, for 10 years if it wasn't the truth. That infringes on the imagined reality you've built around yourself. So I guess I'm the fool after all. So yes, it's always not worth discussing. It's not worth defending your miraculous and super wooey phantasmagorical baby physics. And that's all this is. And you're afraid to defend it. I'm telling you, look, quit whining. I'll pay you to do it. Do it my way. Respond to the videos I've made where I make the point as clear and distinct as possible and then explain where something I said in the video is wrong. Is that too much of a fucking goddamn challenge? 5 minutes. Go ahead and find the I can prove that wrong. Find that. Alright. So, Basin Bass says, why would you divide the velocity, meters per second, by a time, seconds? Let's see. Meters and yeah, I don't know either. When you drive down a highway at 60 miles an hour, that's all you need. 60 miles an hour. That's right. You just count how many hours or how many portions of an hour, and then you just do your divide it time. You multiply it times a fraction, or you multiply it times 3.7. Where is the extra time coming from? How do you not see the contradictions to the mv squared? How do you not see the contradiction to the mv squared? I don't know what that means exactly, but anyway. The meters per second is all you need to determine the velocity because it's already time dependent and you don't need an extra time in the calculation. ms, meters per second, accounts for the distance and the time. We don't drive on a highway saying, yes, we don't drive down the highway saying 60 miles an hour per hour. No, we don't do that. Alright, we just say miles per hour. It's not irrational to point out these contradictions to reality that KE formula seems to create. Well, thank you for the defense. Ian, my friend, I will try to keep your wise advice in mind, whatever the fuck that was. Let's see, he says, Sir Isaac Newton teached us. Sir Isaac Newton teached us. Yes, change in velocity over the change in time is a ratio. That's exactly what he was saying. It's a ratio, right? But if you want to net change, if you want the net change, you don't need the time anymore. All you need is the change in your velocity. The change in your net velocity equals the change in the force. He simply states it. He states it right in his own words. You want to go twice as fast, you use twice the force. You want to go 3 times as fast, you apply 3 times the force. So why do you keep lying about Newton? Alright, but when you start at 0 velocity, you can say this becomes v divided by t, whatever that means. Why? Again, he just asked, why would you divide a velocity by a time? It's already a time. Okay, and you can also use this in a row of individual accelerations for addition. So again, yes, but that's not what we're talking about. We're talking about gravitational acceleration. Let's see, in shorthand notation, but it still works for units. With more baby talk, frankly. That's just nonsense. It's a constant force. I mean, how can you... I mean, I don't even know why you people would keep persisting that twice the velocity is 4 times of something. How can it be 4 times anything? It's twice the velocity. I mean, I don't understand how you think there's 4 in there somewhere. How can you make a 4 out of a 2? I'll take a break. Alright, this one's a little bit funny. So Basin Bass says to Walker, but why would you square the time? You are driving on a highway at 60 miles per hour and you decide to speed up to 65 miles per hour. All that is needed to understand is the change in the velocity, i.e. 5 miles per hour. Why do I need to know how fast I accelerated? Of what value would it be? The net product is I'm going 65 miles an hour. I can't change the net product by changing how long it took to accelerate. It's not going to change anything. Alright, the rate at which you sped up increases by 5 miles while the time is a constant force. Clearly, if it's a constant force that gave you the acceleration, it had to do it in a constant amount of time. So that's the whole definition of a constant force. Oh, people talking. Alright, so he says, how long did it take you to accelerate from 60 to 65 miles per hour? So again, why would it matter how long it took? How does that change how much energy it was? It can't change how much energy it was. Can't change anything about it. It takes a certain amount of energy to make it go 5 miles an hour. You had to add that much energy. I mean, you could make the argument that, yeah, I can take my time lifting something and I can do more work. But I'm really not making any more energy. I'm just wasting it by taking longer. I can't make this do more. Alright. So he says, you really shouldn't talk to Walker. You're just really going to waste your time. We can say it took 5 seconds. So within 5 seconds, I would have gone a mile per second to reach a constant speed of 65 miles per hour. Or if I said it took 50 minutes, then it would take much longer in time to get to the speed you want. If the time it takes to accelerate from 60 to 65 is 5 seconds, then we'd be going a mile for every 1 second until we reach 65, which would take 5 seconds. And again, who cares? All you're saying is it's going to be a certain amount of work moving it 5 extra miles an hour. How long do you decide to do the work over 5 days, or you do the work over 10 milliseconds? What's the difference? It's the same amount of work to achieve 9.8 or whatever the velocity is. To achieve a speed is a certain amount of work. Anyway, then he says, Walker says, but that answer would get plus units, whatever that is, when you follow the method all physics teachers try to teach you. Newton. It's not Newton. They're not teaching Newton. So that's another lie. Okay, here, let me help you with this. Sir Isaac Newton stated. So I just stated what Newton stated. Alright? Twice the force, twice the velocity. 3 times the force, 3 times the velocity. Clear relationship. Newton stated the force equals the velocity divided by the number of units of force. It's not any time in this delta t. The delta t is the number of units of changing time. How many extra bits of time were you in the force? So you're not even getting this right. This is a ratio. Oh, geez, it's just too silly. hence F equals ma. No, F, the force, equals the change in your momentum. That's what Newton said. Newton didn't say F equals ma. He said force equals the change in your momentum. However your momentum changes, that's the force that did it. And force and momentum are interchangeable. If I have momentum, I can create a force that's going to be proportional to my momentum. That is, it's going to be exactly the same as my momentum. The force equals the momentum. So this is all slandering Newton. So I won't bother even reading it. Let's see, and then he says again, more crap. You should try to learn to use equations, so fuck you in the ass, still dead. Alright, Bass and Bass says, talking about distance within 5 seconds, do you not see how saying miles per hour per second is a contradiction? Yeah, exactly. LOL, 1 mile per second is almost the escape velocity of the moon. So what? So that's just changing the subject again. All right. Right. I did make an error. 1 mile per hour for every 1 second, but why square the time? Okay, so it's going on and on. So yeah, I would suggest you just don't bother talking to this guy. But whatever. Go ahead, waste your time. Let's see. So now you are one of us. Okay, let's see what he said up here. I don't see him agreeing with any of this. Right. I did make an error. Okay, no, that's all he said. And now he's saying because he's conceded he made an error that now you're now one of us, and now you can watch the video again. Physics works. I mean, what a pile of shit. What a pile of absolute shit. I'm still learning this stuff, but I do see draft science arguments to be rational and logical, and I want to see this pan out. Yeah. Well, it's only going to pan out when, again, we find some Mythbuster videos, some more kind of real physics, real science, taking the challenge to actually see if they can experimentally pull the truth out without doing rickety, shitty experiments that aren't going to show you the truth. I mean, I realized something about springs. All right, so I'll just throw that in. When you compress a spring, when you're putting the energy in, there's nowhere else for it to go but in the spring, essentially, right? I mean, the object goes all the way in, stops. There's no loss when you're putting it in. But when you're taking it out, there's a problem. So the faster the spring goes when it's releasing the energy, the more likely it is to lose extra energy, right? To keep some of it. So if the spring is moving slowly, so you put a heavy mass on, the spring moves very slowly, the object leaves and the spring bounces a little. But it's just a little bounce because it's a low velocity. But if it shoots a light object, well, the spring relaxes, the light object leaves, and the spring oscillates aggressively. So there's more losses in a spring the faster the release velocity. So I realized that's a real problem. Now another problem in all the experiments people have been doing, I didn't realize, they're putting springs on pieces of wood. That's a bad idea, okay? Because the wood dense. Wood can't, wood deforms. So you really need not to do that. And you have to make sure when you're doing the experiment that you're not doing it on a rickety table. You have to really make sure that it's an anvil. That whatever the experiment, there's nothing in between the experiment and the earth that is a buffer that can vibrate. So you want to you don't even want to put the experiment on, like say you need the experiment to be a little higher. Don't put it on books. Books compress. So they're going to absorb energy. So you don't want to do that. So anytime you have a fulcrum or you're banging something against a wall, you have to really make sure that whatever you have this device on that's going to do this spring measurement isn't on a platform that has any flex in it at all. I mean, my table would not be very good because it's got a lot of heavy shit on it, and it will, it will absorb some energy. Anyway, just a side note. All right, so physicist Michael, maybe I'll take a break and we'll do this last comment. Alright, back. Should be able to finish up here. So he responds to the bass and bass guy. This is physicist Michael. We need to be very careful in distinguishing when we are talking about velocity in meters per second and acceleration in meters per second squared. So right there is the whole argument. Because what's the distinction? An acceleration is merely adding a velocity. That's all it is. You have a velocity, 30 miles an hour. You add 30 more miles an hour. There's nothing new about the thing you're adding. There's nothing different about it. It's not anything different than a velocity. Whether you're adding 5 or 1 or whatever you're adding. And if you're adding it every unit of time, any unit of time, if it's a continuous addition, well, it's in those units of time. But it's not some special second squared thing. It's in a number of seconds, period. It's 30 miles 4 times, or 30 miles 7 times, or 30 miles 8 times, whatever it is. But there's no second squared. It's just nonsense. An acceleration is not any different than a velocity. You're just adding a velocity. You're taking a velocity from over here. You have a velocity. You're taking a velocity from who cares where, and you're just attaching it to this velocity. That's all you're doing. An acceleration is not some kind of different thing. It's exactly the same as a velocity. Oh, it's just terrible. The rate at which your velocity is changing with time. So again, it changes in clumps. Okay? A clump per a unit of time. 9.8 meters per 1 second. You want to say every second? That's okay too. Every 1 second. Alright, this is just straight up the definition of what we meant when we are talking about acceleration. So again, I'm sure this won't convince bass and bass guy anymore it will me. It's a velocity. Okay. In the same way, we define a triangle to be a shape with 3 straight sides. So again, you're saying that an acceleration is distinctly different than a velocity when it connects to a velocity perfectly. There's no seams. It blends right into a velocity just fine. This is also, for now, completely separate from any idea of k equals 1/2 squared. No, how is it separate? How is this absolute contrivance of a squared second not have everything to do with the kinetic energy formula? I'm sure you can trace all of it, its contrivance, its creation, to the same time they contrive the work equation. Alright, we'll get to that later, whatever. So let's consider some examples. Whatever. Examples of what? A squared acceleration? No, sorry. I'm going to keep all the velocities in meters per second to avoid confusion. Well, who cares? Again, suppose a car is going down a highway in a straight line at 15 meters per second. Yes. And suppose you step on the gas for 5 seconds and you increase the velocity by 5. And now you're going 20 meters per second. Well, all you did was add 5 meters of velocity. It is not speeding up, slowing down, or changing direction. So if I look at different times, what the fuck is he talking about? It's not slowing down or speeding up. What do you mean it's not? So 3 seconds later, it's in a perfect environment where it's not going to slow down. Okay, it's moving through space, I guess. I don't know. If we take our definition of acceleration, we note that there is no change in the velocity as time goes on. Yes, we can all note that. It doesn't make any sense at all. It doesn't happen anywhere on Earth. Okay, so the acceleration is 0. Obviously, the deceleration would be the rate of gravitational friction. But anyway. Alright, so now let's say I step on the gas, and over the course of 5 seconds, you apply some unknown amount of force in 5 seconds. Who cares how long you accelerate? The only thing that's going to matter is how much you accelerate. All right, the velocity of the car increases from 15 to 25, so you added 10 meters per second of velocity. That's all you did. I could bang into the car with a car going 25 and accelerate it by giving it velocity. Where's the squared seconds involved? It'd be the same if I pushed it and it went 10 miles an hour. Say it's not going anywhere and I hit it and now it's going 10 miles an hour. Well, now it has 10 velocity, but isn't that velocity an acceleration? When does the acceleration turn into a velocity? When's the special glorious moment that your acceleration, your squared thing, turns into a non-squared thing? I mean, it's too ridiculous. So if we look at the different times, who cares? So we know this isn't how it's added. So that's not even correct, right? We know gravity doesn't add it this way. You know, you don't get 1 meter per second in the 5 seconds. So these numbers wouldn't be accurate for a constant force like gravity. This is some other kind of force, because the constant force like gravity can't do it this way. All right. It gives you, you know, it gives it to you, let's see how to say it. It's incremental and additive. So he's got it going 2 meters per second per second. So he says this, but it's really just 2 meters per second per second. Oh, he says that right down here, 2 meters per second per second. Yeah. So that's the game he's playing. He's applying a 2 meter per second acceleration. So it's as if it was gravity, it would be 2 meters per second. That's all you need to know. It adds 2 meters per every 1 second. That's exactly what it does. 2 meters per every 1 second. Why would I say second squared? If I want to measure my acceleration, it is the rate at which my velocity is changing over time, blah, blah, blah. So I could look at the entire interval and say acceleration change in velocity change in time. All I need is the change in the velocity, frankly. All right. But let's just say that we're going to pretend we're going to, the force we know, somehow we know the force happens every 1 second. So somehow we know that seconds matter. That every 1 second there's a rate of change. Because that's basically what he's saying here, right? That we're just going to pick up the 5 thing and we're just going to divide it to cut it into these 2's. All right. 5 units of 2. So again, still doesn't make second squared make any sense. All right, so he says 25 meters per second minus 15 divided by 5 seconds. And that gives you 10 meters per second divided by 5 seconds. It's just divided by 5. You don't need the seconds. So that's the key right there. You could just understand right there. You don't even need the seconds. You're dividing it by 5 units. The 5 seconds is 5 units. It doesn't need to be seconds. It's just 5. You're dividing it by 5. You're dividing it into 5 portions. You don't need seconds here. All right. Your velocity is changing by 2 meters per second, so the acceleration 2 meters per second squared. So again, it's just totally unnecessary, since the acceleration is constant during this described motion. So again, the squared isn't saying constant, it's saying square something. Okay, so that doesn't make any sense. Again, what does 2 meters per second squared mean? What am I squaring? 1. It's 2 meters per 1 second. You changed it into 1 second units. That was the whole point of dividing by 5, was to convert it into 1 second units. So you convert it into 1 second units. So it's 2 meters, okay, divided by 1 second squared. The 5 changes, is the very point of the 5, is to break it into 1 second units. So it's 2 meters per 1 second squared. So 1 second squared is 1. So done. Yeah, it really doesn't make it circular nonsense. All right, so there's no point. Like I see, since I can't believe he types all this crap. Since the acceleration is constant during this described motion, you can pick that the change in velocity divided by change in time during the interval, say 1 blah blah 3, velocity changes 4 meters blah 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 over 2 blah blah blah. You divided it by how many total seconds, and you're going to convert it into a 1 second force, and that's all you did here. You just converted something you didn't need to convert it, but you decided, I want to know what it is per second, so you divide by 5. But you certainly didn't need the seconds on here. Okay, now to one more case where this is, who cares? Yeah, I can't believe he wastes time on this crap. That anybody could give a shit about this crap. This is not the subject. This crap. You're describing what the fuck a square second is. That's the subject. What the fuck is a squared second? Okay. Note that here we had the same starting and ending velocity, but the acceleration is different because the rate at which the velocity changed is different. Right, so who cares? You're adding or subtracting. Who cares? How does this change anything? So he's going to do the same crap. Your velocity is changing by 0.05 per second. So, and then later you're adding 0.10, and then later you're adding 4, and then later you're adding 6, and then you subtract 6. Who cares? You're still subtracting velocities. You're not subtracting some special squared thing. Anyway. The true value of g is just the acceleration that an object will have if it is free falling only under the influence of gravity. And again, it's not squared. Right. The value of g is just the acceleration that an object will have if it is free falling under the influence of gravity. For 1 second. For 1 second. G only works for 1 second. If you make it any other amount of time, especially a squared time, then it's not going to be 9.8 anymore. It's an acceleration, so the units again are meters per second squared. So just, you says so. Lastly, and this energy thing is an aside, so there's nothing about it that's an aside. All of this frickin' squared crap came out of the same Leibnizian fart. Okay, they're just re-farting an old tired fart. Alright, lastly, and this energy thing is an aside. For an object falling under gravity, in terms of the energy, so again, more baby talk. How much force? Alright, and again, what did Newton explicitly say about force and energy in the sense of momentum? Same damn thing. In terms of energy, the kinetic energy, blah blah blah, that the object gains will equal the amount of gravitational potential energy. So this is more crap about how far or how high you are. So more crap. Okay, PEG equals MGY. I don't know what Y is. So if we're equating these, they must be the same units. Says U. Why would I equate them in the first place? Why would I pretend to think momentum and kinetic energy are the same thing when they're not? K equals 1/2 mv squared. Yeah, the momentum's right there in the middle of it. Has units of kilograms meters per second squared. We got mass of kilograms times velocity squared. So again, who cares? Just nonsense. The point is you're using velocity squared. The point is you're arbitrarily, for no good reason, squaring a velocity. Alright, PEG equals MGY has units of blah blah blah. We got the mass of kilograms times acceleration in meters per second, then multiplied by the fall distance in m. So I guess this is what y equals, is the fall distance. So once again, we already know that the fall distance isn't the force collection distance. That you're only the time is going to tell you how much force you collected. So it's mgt, obviously. So the units at least match up. So again, they match up because they're wrong. It's plainly just simple, okay? You don't collect 4 units of energy. You don't collect 4 units of force. You know, because there's 4 units of distance does not mean there's 4 units of force. Oh, fuck. And there isn't even 4 units of distance. The distance is 4.9, 4.9, 4.9, 4.9, which equals, coincidentally, 19.6, which is your velocity. Anyway. So the unit at least match up, again, in order for the physical equation to possibly value. Oh, this goes on about his little units crap. Like somehow, oh, you mix potatoes with watermelon. Nobody's mixing potatoes with watermelon. Hope this clarifies things. Amazing. So I wonder what Bass and Bass guy will actually say to all this crap. Look, he typed all of this crap as some sort of rationale or excuse for saying second squared when there's just none. Crap. Alright, I'll refresh it, see if there's anything else, and be back. Alright, nothing new. So, 45 comments is kind of funny. It's just... and nothing. I mean, you really can't get anywhere. You know, there's a basic subject. You're just saying, okay, is it, is it real or is it Memorex? You know, there's just a simple truth to define here. And the fact that they won't even accept the underlying truth, which is you can't believe in both things. You can't. You really have to choose what really runs the universe, momentum or kinetic energy. Because in every single case where you're ever going to have two things that aren't the same collide with each other, momentum and kinetic energy can't be conserved. The exchange just can't happen. If you conserve the momentum, you can't conserve the kinetic energy. It's not possible. And vice versa. So we know this, it's about one or the other, and you're still not proving why momentum, the idea that one atom moving 1,000 miles an hour is the same as 1,000 atoms moving 1 mile an hour. And again, I could go back to the spaceship, and if that's what I actually threw out of a spaceship, I threw one atom going 1,000 miles an hour out one side, and I threw 1,000 atoms going 1 mile an hour out the other side, my ship isn't going to turn. And that truth should mean something to you people. But it doesn't. Because you can only say because you suck. You suck at making an argument. You won't sit there and say, okay, I have to come up with a counter argument to that. I really do have to explain why that's true. Why is it true that the spaceship won't turn? If there's 1,000 times more kinetic energy, that is 1,000 watts more going out one side than watts going out the other side. One side has 1 watt. The other side has 1,000 watts. It should change how the ship moves. So if it's really true that it actually is 1,000 watts that left one side and only 1 watt that left the other side, wouldn't I be just a complete asshole to sit there and pretend that isn't a significant problem? I mean, don't you people have to be like just complete assholes to ignore that simple argument and pretend it doesn't matter or it's not important? So what? It doesn't move the spaceship? So what? The watts aren't real? So what? Really, that's the crux of this whole thing, is the fact that they won't explain to me, or to Bass, or to anybody else who objects, well, what's real? The momentum that says I shot the same stuff out both sides, and frankly the spaceship's obeying the momentum rule, or the kinetic energy, where the kinetic energy says I put real watts, real joules of energy going this way, 1,000 times more of it this way than I went that way. Why didn't my ship turn? Answer the frickin' question, with some sort of honesty, and admit, well, it's just one of the magical paradoxes of nature. And why don't you say some kind of bullshit like that? It's just the way nature. Don't tell nature how to be, right? Isn't that the famous Bohr line? I mean, Einstein says God doesn't play dice with the universe, and Bohr comes back with, "Don't tell God what to do." God damn, pathetic. This is your science. This is These are the icons of your science. People who talk about not telling God what to do, and people who invent solitons. Not a very credible origin for your Ark of the Covenant. Yeah. For your Holy Grail. Ugh, crap. This really is. It's just, this is just religion 3.7. You know, it's just another religion. Physics.